Hi everybody. In this video we're going to look at a new type of factoring called a difference of squares factoring. And to warm up we're going to look at some distribution again because remember factoring is just the reverse order of distribution. You're undistributing. So let's take a look at these three warm-up problems. In these three warm-up problems, these are each called binomials. So we have a binomial times a binomial. Well, to multiply binomials, some of you may have learned the phrase FOIL, which means multiply the first two terms together, then multiply the outer two terms together, then multiply the inner two terms together, and then multiply the last two terms together. So let's see what I'm talking about here. It's basically a double distribute. So if I multiply the first two terms together, that is x times x, which is x squared. Then multiply the outer two terms, so I've got an x times negative 4, which is negative 4x. So that's distributing this x to both of the terms following it. Now I need to go back and pick up the 4. I stands for the inner two terms, so positive 4x times x is positive 4x. And then L stands for the last two terms, so positive 4 times negative 4 is negative 16. Okay, so I've multiplied all four terms, and look what happens here in the middle. The negative 4x and the positive 4x would cancel each other out, so we would just have x squared minus 16. Okay, let's follow the pattern again. The first two terms on my second example, 5m times 5m. 5 times 5 is 25. M times m is m squared. Now for the outer two terms, 5m times negative 1 is negative 5m. Now for the inner two terms, positive 1 times 5 is positive 5m. And now for the last two terms, positive 1 times negative 1 is negative 1. Well, it's happening again. Look at these two inner terms. A negative 5m and a positive 5m are going to cancel each other out. So we'll just have 25m squared minus 1. Okay, one more multiplication example. Foiling our two binomials over here. First two terms, 2a times 2a. 2 times 2 is 4. A times a is a squared. Now for the outer two terms, 2a times negative 3b. 2 times negative 3 is negative 6, and a times b is ab. Now for the inner two terms, positive 3b times positive 2a. 3 times 2 is positive 6, a and b is ab. And now our last two terms. Positive 3 times negative 9 is positive 3 times negative 3 is negative 9, and b times b is b squared. Well, you guys, it did it again. Look at those middle two terms now. You've got a negative 6ab and a positive 6ab. Those are like terms, and they cancel each other out. So what's left is just 4a squared minus 9b squared. So this pattern happens every single time, and that's because what's left is called a difference of squares. And let's break that down. Difference is the subtraction. Squares is that everything in the problem is a squared term. X squared, 16 is 4 squared, 25 is 5 squared, 1 is 1 squared, and so on. So this is called a difference of squares, and that's what we're going to be working on today, is how to start here and finish with the two binomials. Okay? All right. So here's some steps to get us there. Step 1. First, make sure you have an actual difference of squares. Okay, there must be a subtraction sign, and you have to be able to square root both terms. That's very important. So here's the pattern that's going to happen. If you have a subtraction sign and you can square root both terms, look at the pattern from our original setup. It's going to have one binomial with a plus sign in it and one binomial with a minus sign in it. And we are taking the square root of the final product. So this would be a regular A and a regular B for each term. Now that's just a pattern to help us memorize what's going to happen each time. If you need to think that one through, take a look at our work again. Let's go with this middle term. If we take the square root of 25, we get 5. If we take the square root of 1, we get 1. So when it says we have to be able to take the square root of both terms, that's what we're talking about. We're trying to find the A and B, the square root of what's on the page. And then you can always check our work by distributing just like we did here in the warm-up. All right, let's get busy in some practice problems. Directions say factor each difference of squares, check your work by distributing. If a polynomial can't be factored, it's because it's a prime polynomial. All right, so first, make sure you have an actual difference of squares. There is a subtraction sign, that's good. And I can take the square root of 1a squared, and I can take the square root of 4. All right, so if you want me to write that out, I could. The square root of 1a squared would be 1a. The square root of 1 is 1, and the square root of something squared is just that value. The square root of 4 is 2. So when I set up my pattern, a binomial with a plus in it and a binomial with a minus in it, the terms, the terms that go into the pattern are the square roots of the original. So 1a in the first position and 2 in the second position. Now, if you don't want to write your answers with a 1 in front of the a, that's fine, because there wasn't a 1 in front of the a anyways. So now let's go through and distribute. 1 times 1 is 1. A times a is a squared. We know from our warm-up that all the outer and inner multiplications are going to cancel out. So now I'm going to check my final part by just doing the last two terms. 2 times negative 2 is negative 4. So to check your work, you can really multiply the first two and multiply the last two, as long as you're following the pattern. All right, let's try again. Again, for number 2, you can put a 1 out front if you want to. So we're going to make sure this is a difference of squares. There is a minus sign between them, and we have to be able to take the square root of each of these terms. So the square root of 1n squared, let's think it through. The square root of 1 is 1. The square root of n squared is just n. We also have to be able to take the square root of 64, and the square root of 64 is 8. So set up my factors. 1 has a plus in it, 1 has a minus in it, and these become the terms inside the factors. 1n in the first position and 8 in the second position. I don't typically write the coefficient if it's a 1. We understand there's a 1 there. So let's check our work by multiplying the first two terms together. N times n is n squared. And then multiply the last two terms together. 8 times negative 8 is negative 64. Good deal. All right, don't be freaked out by number 3. It's still a difference of squares. There's a minus sign here. And both terms can be taken, we can take the square root of both terms. The square root of 81 is 9, and the square root of x squared is just x. So we set up our polynomials, we set up our factors with a plus and a minus in it following this pattern. And in slot number 1, we put a 9, and in slot number 2, we put an x. And then check your work. 9 times 9 is 81. x times negative x is negative x squared. Okay, I'm going to start skipping around a little bit to find some other things to show you. For example, look at number 5. This is not a difference of squares. That's not a minus sign. So this is prime. We will not be able to factor that. All right, let's head on down the page a little bit. Let's try something with some bigger values here. Check out number 9. It does have a minus sign in it. That's good. And then let's see if these two terms can have a square. We can take a square root. The square root of 16 is 4. The square root of a squared would just be a. And the square root of 121 is 11. So this does qualify for the difference of squares pattern. Positive binomial, negative binomial. Position 1 goes with the 16a squared, so those are the 4 a's. Position 2 goes with the 121, so those are 11's. And then check your work. 4 times 4 is 16. A times a is a squared. 11 times negative 11 is negative 121. Excellent. Okay. One more on the front here. What do we do if there are more than one variable in the problem? So check out number 11. All right, first of all, it's a minus. That's good. And let's take our square roots. The square root of 4h squared. Square root of 4 is 2, and square root of h squared is just h. Square root of 25g squared. Square root of 25 is 5, and square root of g squared is g. So every term in the original problem is a square term. Set up my binomials and insert my square roots. 2h in the first position, 5g in the second position, and then check your work. 2h times 2h is 4h squared. 5g times negative 5g is negative 25g squared. Okay, if you are getting the hang of this at any time, stop the video and go practice. Okay, I do want to show you something special back here. Look at the back. Okay, we may have examples that have a GCF built in. So it kind of looks like these might not be difference of square problems, but if you take the GCF out first, you'll find that they are difference of square problems. So here's what I mean. I do see that that's a minus, so that's part of difference of squares. But if I try to take the square root of 2 or the square root of 72, I'm going to get a decimal. So it doesn't look like a difference of squared problems. So look at my hint right here. Look for a GCF first. Okay, we have to look for a GCF first. So let's try 21. The GCF of 2 and 72. Well, this should be a pretty quick one because 2 can only be divided by 1 and 2. 72 can be divided by a ton of things, and I'm going to speed through that. It can be divided by 1, 2, 3, 4, not 5, can be divided by 6, not 7, can be divided by 8, can be divided by 9, and the way I know that is 8 times 9 is 72, 6 times 12 is 72, 4 times 18 is 72, 3 times 24 is 72, 2 times 36 is 72, and 1 times 72 is 72. I'm not going to put all those rainbow arches in there. I'll get in the way of number 23. But really, most of this was unnecessary. If the biggest number is 2, I could have stopped right there because I'm looking for the biggest number present in both terms. So here the GCF is 2. So I'm going to divide everything by 2. That would leave me with 1 on the n squared, and 2 times 36 is 72, so that will leave me with 36 here. Don't forget to put that GCF out front because that's reverse distributing there. Now look at what's left inside of the parentheses. This is a difference of squares. We know we can take the square root of n squared and get n, and we can take the square root of 36 and get 6. So when I write up my final factors, I'll have the 2 out front, that's the GCF, as well as the pattern from the difference of squares. N times n is in the first position, and 6 times 6 is in the second position. You need all 3 things to represent your final factored form. The 2 is the GCF, and the n plus 6, n minus 6 is the difference of squares. Let's come on down the page and try another one here. Let's try out number 29. I've got 36p to the third minus 9p squared. It almost looks like a difference of squares. 36 is squared and 9 is squared, but the p's are messing this up. So first thing I have to do is look for a GCF. GCF of 36. There's lots of numbers that divide into 36. 1, 2, 3, 4, 9, 12, 18, and 36. How about the GCF or the factors of 9? That's a shorter list. It's just 1, 3, and 9. Now, if I did that too quickly, come see me because we've got to get you faster about getting the GCF term here. The greatest common factor is 9. So I can take a 9 out of both of these terms. Now, put your attention towards the variables. There are 3 p's in the first term, only 1 p in the second term. I'm trying to teach you, in order to find the variable GCF, take the variable with the smaller exponent. So here it would just be 1p. So divide by that GCF, and let's see what's left. 36 divided by 9 is 4. If there are 3 p's on top and 1 p on bottom, one of those p's is going to cancel out, so there will still be 2 p's in the problem. 9 divided by 9 is 1, and then these p's will just cancel each other out, so there will be no more p's. So there's my GCF step. Now check out what's in parentheses. That is a difference of squares. It's got a minus sign, and the first term is squared and the second term is squared. So I take my square roots and I'm done. The square root of 4 is 2, and the square root of 1 is 1. Set up my pattern for a plus and a minus. The 2p goes into the first position, and the 1 goes into the second position. So I've got my GCF of 9p, and then my difference of squares of 2p plus 1 and 2p minus 1. All right, guys, keep practicing. You've got tons of practice problems here, so try a bunch of them until you're feeling really confident. Come check your answers on the answer key and let me know if you need help. Happy studying!